Hello, in this video we are doing Newton's second law, particularly the applications of Newton's second law. So we are going to talk about how to calculate the normal force, how to calculate a frictional force, which questions are expected, how to draw the free body diagram, okay? Now let's start with the normal force. First of all, let's just define the Newton's second law. Newton's second law states that when the net force acts on an object, the object will accelerate in the direction of the net force with acceleration that is directly proportional to the net force and inversely proportional to the mass of an object. As the net force increases, acceleration increases. If the net force decreases, acceleration decreases, okay? But if the mass increases, acceleration decreases. But when the mass decreases, acceleration increases, okay? So, sityosibe ne-formula at F net that we are going to use when we calculate any force, any mass, or the acceleration. F net is equal to ma, okay? So F net is a resultant force, that is the total force. All the forces are there, linear forces, okay, and is equal to mass times acceleration, right? Then let's talk about the normal force. The normal force is a force surface exerted on an object in contact with. The normal force is a force surface exerted on an object in contact with it, and it must always be perpendicular to the what? To the surface. So the surface, this is the normal force, okay? Then we also have a frictional force. Frictional force is a force that opposes the motion of an object, and it always acts parallel to the surface. So a frictional force will have a maximum static friction. We also have a kinetic friction. So for maximum static friction, F net will always be equal to 0 because the object is not moving there. So for a frictional force, the kinetic friction, F net can be equal to 0 or cannot be equal to 0. It will depend on the situation. If the object moves at constant speed, F net is equal to 0. But if the speed is changing over time, F net is not equal to 0, all right? So let's focus on the normal force now to draw the free body diagram, particularly power normal force. So a normal force is a force exerted by the surface. So we have two kinds of or types of surface. We have a surface which is horizontal surface. We have inclined surface, right? Inclined surface and the horizontal surface. So let's say we have an object here, 2 kg. Then we have the same object there, 2 kg. So in this object, we apply a force, maybe 50 newtons. We also apply the same force, which is 50 newtons. So obvious, this object will move in this direction, will go in that direction. Here, obvious, the object will move up and incline, okay? Now let's draw a force diagram. Normal force is a force that always perpendicular. If we talk about the normal force, we must see perpendicular to the what? To the surface. This is the line for the surface. Then the normal force must be perpendicular to the surface because the surface pushes this object up. So the normal force is in that direction, perpendicular to the what? To the surface. Also have the weight, it is always vertical. Then the frictional force opposes the motion of an object and acts parallel. Remember, parallel means to have parallel here, you can put another line like that. So that is a what? A frictional force. Since the object is here in that direction, the friction will oppose the motion there. That is the force diagram. That is the force diagram. Therefore, the free body diagram, no object. The object here is represented by the dot. So it's the normal force bar, then the weight, then the friction, and the force applied. That is 50 newtons of force applied. Let's come to this one. This is the surface. The surface pushes the object in this direction. The surface pushes the object in that direction. This is the normal force. The frictional force must be parallel to the surface. This is the line of a surface. So the frictional force must be parallel. This is the first line. Another line can be like that. That is parallel to the surface. So we have weight in that direction. So the free body diagram here will be the force applied. That is what? 50 newtons. We will have a friction in this direction. That is friction. Then we have a normal force in that direction. Just copy. Then we have a weight downwards. Always we have a weight. So that is the free body diagrams. So this is how we draw the normal force, right? Now, let's draw different free body diagrams and which question can be asked in each free body diagram. Okay. Now we have the object on the horizontal surface, which is 2 kg. Then the force is applied. Trying to draw a straight line there. 2 kgs. The force is applied, which is 50 newtons, right? So the first question that can be asked beside defining Newton's law, first, second, third, or normal force or frictional force, the second question there can be draw a labeled free body diagram. And let's assume that the surface is frictionless in this case. The surface is frictionless. So when you draw a free body diagram, there is no friction here, okay? But the normal force is a force exerted by the surface on this object, and it must act perpendicular to the surface. Now, yeah, that is the word, the normal force. Also have the weight. This is the weight, okay? This is the weight, right? So the free body diagram here, we have the normal force, we have the weight, then there is a force applied, which is 50 newtons, all right? So after you have drawn the free body diagram, the first question maybe can say calculate the normal force. Calculate the normal force. So how to calculate the normal force? These forces are equal in the opposite direction, meaning that F net there is equal to 0. Which means when you calculate the normal force, F net is equal to 0 always. F net is equal to 0 when you calculate the normal force. Then this one is positive, this one is negative. So normal force minus weight is equal to 0. Since the question says calculate the normal force, we are going to focus only on vertical forces because the normal force is a vertical force there. Then you are going to calculate the weight. Weight is equal to mg. Then you substitute to get the normal force. Another question that can be asked you on a free body diagram like this one, they can say calculate either the acceleration or the force applied. Which means upper you'll be given maybe the force applied, then you are required to calculate net force, acceleration, or you are given the acceleration, you are required to calculate the F applied. In this case, the acceleration is already given, so we need the acceleration. So the formula will be this one. F net is equal to ma. The object moves horizontally, which means we are going to focus only on horizontal forces. Since the question says calculate F or acceleration, we are going to focus on the forces that are parallel to the surface. Okay? Are parallel to the surface or are parallel to the displacement. Alright? So, in this case, how many forces do we have as horizontal? We have only one force. This one must be positive, which means our net force is that force applied. Force applied is equal to MA. The force applied is 50 then, 50 newtons. The mass is 2. Then acceleration is what we are looking for. Then we are going to divide by 2. Then you get the acceleration, which is 25 in this case. Okay, that is the second question that can be asked here. That is the only question. With number 1 and number 2, we have this one. We can calculate the normal force. The same question, we can calculate the what? We can calculate the acceleration or the force applied. Okay, now let's assume that there is a friction. Let's assume that there is a what? A friction. Which means the surface in this case is rough. We have a rough surface. When they say the surface is rough, which means there is a friction. The normal force is still that one, the weight is that one, the force applied is that one, but there is a rough surface, which means there is a friction. The friction always opposes the motion. This object is supposed to move in that direction, which means the friction must act parallel in this direction. This is parallel, that is a friction. So the free body diagram that we have, it's a normal force, it's a weight, it's a force applied. Then we have a what now? A friction. The first question here can say calculate the normal force, obvious. Calculate the normal force. Right? So normal force is, and calculate the normal force, which means we're going to focus on the vertical forces. F net is equal to 0, normal force. So this one is positive, this one is negative. Normal force minus the weight is equal to 0. Then the weight, I said, it is equal to mg. Okay. Then the second question, now that there is a friction, after calculating the normal force, they can say calculate the kinetic frictional force. Kinetic frictional force. The formula is Fk is equal to the mu k times the normal force. Remember, the normal force is on step number 1. You just take this normal force and substitute here. Okay, so you get the frictional force. Then the last question that can be asked, calculate the force applied or acceleration again. Now that we have the force applied, the question will say calculate the acceleration. So we use the horizontal force. F net is equal to ma. So we are going to use the horizontal forces. Okay, Masia, we have how many forces now as horizontal? Z2. This must be positive, friction must be negative. So friction is negative, but force applied is positive. Friction is negative, the kinetic friction, which is equal to ma. Then we already calculated the friction on step number 2. Then we want what? The acceleration. Force applied is given, so we use this one. So that is second question. Now let's look at another scenario that you can have. quickly. We are still on horizontal surface. Still have that 2 kg, but the force now is applied at this angle, which means from 0 we increase the angle to 30 degrees. Okay. So the first question is say draw a labeled free body diagram. Okay. So the labeled free body diagram, the normal force is a force exerted by the surface. The surface will push the object up. Normal force, the weight is always downwards. Now let's just say there is a friction if the surface is rough surface. So there will be a frictional force there, and it must always be parallel to the what? To the surface. So the free body diagram that we have, Nanzia, 50 newtons or force applied, frictional force, weight. Now that we have vertical forces and horizontal force, but at an angle, we need to resolve the components. We only need forces that are perpendicular and parallel. So we have a normal force, we have a weight, we have a friction. Then this one will have components. We will have Fy and Fx. Fy and Fx. Fy is F cos theta. Fy is F sine theta. Okay. Now the first question can say calculate. This is for calculations. This free body diagram. But this one is just for exam purpose. How to draw a free body diagram as it is. Then for calculations you must have another one, which is this one. Okay. The first question can say calculate the normal force. Calculate the normal force. Now, normal force is the force is vertical. Is a force here. Where is this vertical? Right? That is the normal force. This one is positive, this one is positive, this one is negative because it is in the opposite direction as is here. But always when we calculate the normal force, we say F net is equal to 0. So we have normal force positive, we have Fy positive, but the weight is negative, which is equal to 0. So you will calculate Fy. After Fy, you calculate the weight, then you substitute to get the normal force. The second question can say calculate kinetic friction. Calculate the kinetic friction. We're going to use Fk is equal to mu k times the normal force. Remember, the normal force is calculated in the first question. Then you just substitute. The coefficient of kinetic friction will be given. The last question can say calculate force applied or calculate acceleration. Now that we have the force applied, we are going to calculate the what? The acceleration. So in this one, we are going to use F net is equal to ma only on the horizontal forces. Okay, on the horizontal forces. Upper we have this one and this one. This one must be positive, this one is negative. Okay, so F net will be Fx minus Fk, which is equal to ma. Then we calculate this one first, then we get substitute here, it's just the acceleration. So what if we are given the acceleration and the force applied? Obvious, maybe the first question can say calculate acceleration. Now the acceleration is given. The second question say calculate the what? The frictional force. We are going to use F net is equal to ma to get this one. Then from this one, you can get the normal force. See that they say calculate the normal force from here. From the normal force, calculate the frictional force. You're going to use that one. Then from the frictional force, calculate the acceleration. Or they give you the acceleration. You start here. So step number 3, 3, 2, 1, or 1, 2, 3. So it goes like that, okay? Then let's have another scenario. Another scenario. So neuklalo ready. Pushing force. Right. So let's draw the free body diagram here. We have this force in this direction. That is force applied. That force is force applied. Then we have a normal force and here. Then there is a friction if the surface is rough. Let's assume that the surface is rough. And there is friction. Okay, so the free body diagram will be like this. There is a bullet here. There is a force in that direction, force applied. Then there is a normal force in that direction. I forgot to write the weight here. There is a weight downwards. Then there is a friction in this direction. Then for calculations, we have another free body diagram. So for calculations, now that this force is landed, you must have the components. So we have a weight downwards, we have a normal force upwards, we have friction to the left. Then this one will have a component down and a component to the right. So we have a component down, that is Fy, and a component in that direction, Fx. Okay? So the first question will say calculate the normal force. Calculate the what? The normal force. How to calculate the normal force in this case? This one must be positive, this one is negative, this one is negative, but F net is always equal to 0 for normal force. Okay? So normal force is positive, minus Fy minus weight is equal to 0. Normal force is positive, this one is negative, this one is negative. Then we get the what? The normal force. Then number 2, you have to calculate the friction. Calculate the friction. Or the kinetic friction, right? Kinetic friction. So Fk is equal to mu k times the normal force. The normal force is already calculated in question 1. Number 3, can say calculate the acceleration, or they can say calculate the force applied. Now the force applied is already given 50 newtons, so we can calculate the what? The acceleration. When we calculate the acceleration, F net is equal to ma. The focus is on horizontal forces. Says if horizontal forces are says 2. This must be positive, this one must be negative. Fx minus F friction, which is equal to ma. Then we calculate the acceleration. So kuzo zonke we always have almost as questions over as we train, maybe but you have to start calculating the normal force before calculating the frictional force. Okay, if they go straight to this one, calculate the acceleration, you need to have the friction. To get the friction, you must have the normal force. Okay, let's have only one from incline, maybe 1 or 2. So the surface now is changing to incline. Let's say we have an incline surface, 30 degrees, 2 kg is there. Then we have a force applied, 50 newtons. First question, obvious, draw a free body diagram. So we are going to have a weight downwards, always. Then the normal force, this is the surface. Normal force is the force exerted by a surface on an object. So the surface will push this object in this direction, which means the normal force will be in this direction. That is the normal force. Then the friction opposes the motion parallel. So now parallel. Then that is a frictional force. So we have a normal force in that direction. We have a force applied in that direction. We have a friction down an incline. We have a weight which is always vertical. For calculations, we incline. We have a free body diagram of calculations. So we have a normal force. We have a force applied. We have a friction. We have the components. It's a weight that is perpendicular to the surface. Then we have a weight that is parallel to the surface. Okay? So question you can say calculate the normal force. The normal force. But we know that F net is equal to 0 for normal force. This must be positive up, this must be negative. So the normal force, now the normal force says 2. So weight is negative, weight perpendicular, plus the normal force is equal to 0. Weight perpendicular is always equal mg cos theta. Then you get the normal force. Number 2. Calculate the friction. Calculate the kinetic friction. So when you calculate the kinetic friction, we just use this formula. Then number 3, remember the normal force is calculated here. The coefficient of kinetic friction is given in the statement. The last question can say calculate the magnitude of acceleration or the magnitude of the force applied, since in new kappa. Okay, so in this one we are going to use F net, which is equal to MA. Ihamba kanjani ke object ihamba kanje, which means nazi ngesithetha ngazo forces. This one is positive, this one is negative, this one is negative. So we have force applied positive minus weight parallel minus weight frictional force, kinetic friction is equal to MA. The weight parallel is equal to mg sine theta. Then we're done. Okay. Then let's have the last one. The last one for now. Maybe we have a table. We have something here. Let's say it's a motor. There's a pull here. There's the object here. Maybe it's 2 kg. The motor pulls the object up, which means the motion of the object now is in that direction, upwards. Okay. So the free body diagram, we have tension here, tension on force by motor. We have a weight here. So we have only, if we ignore the F friction, we'll have the tension or the force by motor. Then we have a weight. Okay. And remember the motion, it moves up, which means this one must be positive, this one must be negative. So F net is equal to MA. Tension minus the weight will be equal to MA. Then we calculate the tension, or we calculate the force applied, or we calculate the mass, but any question that can be asked there. Thank you.